Models of the solar system. Let's start with the geocentric model. The geocentric model had the Earth in the center of the solar system. Up until 1543, people believed that the Earth was in the center of the solar system. All the objects in the sky, called celestial objects, orbited the Earth. Orbiting closest to the Earth is the Moon. Next was the planet Venus. Further away, the Sun. Beyond the Sun was Mars, and beyond Mars were other celestial objects like stars. These objects orbited the Earth or went around the Earth. Why did people believe this to be the case? The visible evidence that they saw was the motion of the Sun. The Sun appeared to move through the sky. People on Earth did not feel like they were moving, but when you watch the Sun during the day, it appears as if the Sun is moving and the Earth is standing still. Another piece of evidence they had was the motion of the Moon. During the nighttime, the Moon appears to move through the sky. The third piece of evidence they had was the motion of the stars at night. If you watch a star during the nighttime, you'll see that it will move through the sky as time goes by. The fourth bit of evidence we have is really just how people felt. People didn't feel like they were moving. They felt as if they were standing still, and all the objects that they observed in the sky appeared to be moving. The heliocentric sun-centered model was adopted in 1543 based upon the work of an astronomer named Nicholas Copernicus. This is the model that we have today, with the sun in the center and the planets orbiting around the sun. So what evidence was there that the Earth was going around the sun and not the sun going around the Earth? The orbit of the Earth around the sun is called the Earth's revolution. First bit of evidence we have is at different times of the year, there are different constellations in the nighttime sky. So with the Earth going around the sun, during the summertime, you'll see the nighttime sky is over here. The darkened part is the nighttime sky. The sun's lighting up the side. When a person looks out into space, they'll see groups of stars that make patterns in the sky. For example, during the summertime, you might see a group of stars that makes a cross in the sky. It's called the summer cross, or actually it's called Cygnus the Swan. During the summer, you can see Cygnus in the nighttime sky. Now, because the Earth is going around the sun, when we get to wintertime, we're on the opposite side of the sun over here, and we no longer see Cygnus in the nighttime sky. Looking out at the nighttime sky, we see other constellations. In the wintertime, the most probably famous one is Orion, easily seen in the nighttime sky. The Earth is going around the sun. The result is that at different times of the year, there are different constellations in the sky. So our first bit of evidence that we'll list here is number one, changes in seasonal constellations. The second bit of evidence has to do with an optical illusion known as retrograde motion. Let's take a look at three planets, with the Sun here, Venus here, Earth here, and Mars here. As the planets go around the Sun, planets closer to the Sun go faster than planets away from the Sun. So imagine that an observer on Earth is looking at Mars. Because Mars isn't moving as fast as Earth is, Earth moves ahead of Mars. And when Earth passes Mars, Mars appears in the sky to be moving backward in its motion. This occurs with any planet that's further away from the Sun. When the Earth passes the planet itself appears to be moving in the opposite direction. Number three on the list. The original premise of the geocentric model was that everything orbited Earth. Using a refined telescope, Galileo discovered that not everything orbited the Earth. In fact, Jupiter had moons of its own. Discovering the moons of Jupiter refuted the idea that everything orbited the Earth. Because of its position between the Earth and the Sun, different portions of Venus appear to be lit up in producing the same pattern as the phases of the Moon. Phases of Venus appears to change in appearance. So by 1543, people had an idea that the Earth was orbiting around the Sun. We also had an idea that the Earth was spinning or rotating. The first bit of evidence we have is a phenomenon called the Coriolis effect. Coriolis effect is the deflection of an object as it moves through the atmosphere or through a liquid. This deflection in the northern hemisphere results in an object veering off to the right. This is due to the spin of the Earth. We will go into more detail as to how the spin of the Earth causes this effect to happen in the future. The second piece of evidence we have for the Earth's rotation is the Foucault Pendulum. A pendulum is usually composed of a ball on a string that swings back and forth. The phenomenon of the Foucault Pendulum shows that if a pendulum swings freely back and forth, over time it will appear to change its position. So what do we know about the Earth's orbit? So the Earth's orbit is not a perfect circle. At times we're closer to the sun, and at other times we're further away. It takes about 365.25 days for the Earth to go around the sun. In this shape here, we have about 360 degrees to go around to return to our initial point right here. And there's about 365.25 days to complete one orbit around. So if we take 360 and divide it by 365.25 days, we're getting around 1 degree per day of motion. Another interesting aspect about the Earth's orbit is the fact that the moon orbits the Earth. So the original view of the geocentric model with the Earth in the center was wrong for the stars and for the sun and for the planets, but was correct for the moon. The moon does orbit the Earth. As the Earth orbits the sun, the moon orbits the Earth. So a quick review, models of the solar system. The geocentric model has the Earth in the center. The moon orbits the Earth, Venus orbits the Earth, the sun, Mars, and then the stars. Evidence, motion of the sun, motion of the moon, motion of the stars, and people didn't feel like they were moving. The heliocentric model, adopted in 1543, has the sun in the center. Evidence includes, at different times of the year, there are different constellations in the nighttime sky. So during the summer, we see a certain group of constellations. During the winter, we see a different group of constellations. As the Earth moves around the sun, it moves faster than the outer planets. Therefore, it passes the outer planets, giving the appearance as if the outer planets are moving backward. This is called retrograde motion. Then we have the moons of Jupiter, prove that not everything orbits the Earth. The phases of Venus, that Venus appears to change in appearance, just like the moon does. Evidence of rotation, we have the Coriolis effect, the Foucault pendulum, and saying that the Earth rotates gives an explanation for the motion of the sun, moon, and stars. Important things about the Earth's orbit: it's not a perfect circle. It takes 1 year to go around the sun, moves about 1 degree per day, and letter D on the list here, as the Earth orbits the sun. Remember, the moon does orbit the Earth.